This is the first step in the process of using experimental data to determine chemical formulas. Although actually what we're going to do is work backwards. We're going to assume we already know the formula and work backwards and find out how much of things were involved in that, because ultimately we're going to go the other direction. This is called percent composition by mass. This might be the second easiest thing you'll do all year, mathematically. Okay? If I have, you guys ever seen brown eggs? Yeah. You seen brown eggs? You guys like brown eggs? Okay, you know there's no difference in taste, right? Yeah. Okay, so it doesn't matter. Anyway, where I'm going with that is, let's say I had a dozen eggs and 3 of them were brown, the rest of them were white. What's my percent of brown eggs? My percent of brown eggs. Oh gosh. I have a dozen eggs, of which there are 12. 3 of them are brown, the rest of them are white. What is my percent of brown eggs? Thank you, Gunther. Gunther said 25%. Is that correct? 3 divided by 12, 25%, right? So when you find percent, you take the part that you're considering and divide that by the whole, right? You guys are getting percent, and multiply by 100, okay? That's exactly what we're going to do here. We're looking for the percent percent composition by mass of each element in a compound. So let's do something incredibly easy. Let's look at sodium chloride, since we mentioned it earlier. If I want to find the percent by mass of each element in sodium chloride, what do I need to know? Well, I need to know the mass of the sodium that's in sodium chloride. So, what is the mass of, how many sodiums are there? 1. And what's the mass of sodium? 22.99 grams. How many moles of chlorine? 30, there's 1. And the mass of chlorine is 35.45. Now, I know this is incredibly easy for you guys. I'm going to add all those up. I'm going to get 58.44 grams of sodium chloride. You'll know that one too before it's too long. Okay? Now, what if I wanted to know the mass of sodium? What would I do? Or sorry about that, the percent of sodium. What would I do? Divide by 58.44 grams, multiply by 100. Divide by 58.44 grams, multiply by 100. Boom, 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 boom. Anyone like to shout out a result of either of those? Alex, which one are you doing? The sodium? Okay, and then anybody else have a calculator they're pressing right now? Gunther, could you do the chlorine?
Yeah.
Alex, what do you got?
39.3%.
39.3. Let's go to 4 significant figures.
4.
What is the percent?
It's 39.3395.
So, you're right. Okay. And Gunther, what do you have?
60.66.
Now, that could have been easy since there were only 2 elements. We could have just subtracted from 100 or actually do the calculation. How hard is that? Not very hard at all. So, let me step up the game a little bit. Next example. Hashtag 2. I had people say, Mr. Laban, why do you have hashtag 159.6 up there? Anyway, moving on. Example number 2. Let's find the percent composition by mass of Jenna. I just need an element. Ooh, she's going to make this fun. Let's go with mercury to phosphate. Nice. Mercury 2 phosphate. What's the percent composition by mass of this? Well, I know that you guys can do this, but let's do it for fun. How many mercuries? 3. What is the mass of 1 mole of mercury? Oh, yours says 6? Ah, okay, I'm used to remembering as 200.59. All right, so 200.60 grams per mole. What's the mass, or sorry about that, how many phosphorus atoms? Everyone together now. 2. Excellent. And phosphorus, as we all know, is 30.97. And how many oxygen atoms? 8. Say this again.
2.
8. All right. Can I let you guys run with that? I'm going to let you guys run with this. Thomas, that means you have to do it. You're just sitting there. Okay. Let me ask you this, Thomas.
What?
Were you going to go home this weekend and watch the video and take notes from the video?
Yes, my dad.
Okay, and
told
that's
me
fine.
He needs to see videos. He has trouble trying to play.
I'm okay with that.
So-
Then if you want to, just pay attention.
Yes, I was.
But at least do the calculations. So we're looking at 600 and 601.8. 601.8.
Yes.
62.94. 61.94. My bad. God, that was dumb. 61.94.
Yeah, and 120.
Okay, and then geez, 428. You guys got to know your multiples of 16. I think I told you about that, didn't I?
Yes.
Okay, and so we add all that up. We get a 4, we get a 7, 11, 9, and 191.74.
791.
What'd you say?
I said 791.74.
791.
What'd you get?
791.4 or 0.74. I think you have 190.
Oh, 600. I thought I got. Oh, I did that wrong. My bad. I'm not used to 600. I'm used to like things like 90. So anyway, 7 right here, 8, 9 right here, right? So 791.74.
Yeah.
Excellent. Okay, and that's of the what do we have? Mercury to phosphate, right? So we divide each of these by 791.74. Multiply by 100. You can set these up any way you want. Doesn't matter how you set them up. I don't know. I started doing it this way a couple years ago just because I got bored. So I tried to do it the other way. Anybody have values yet for the percents? I'm gonna guess the mercury's pretty high. What'd you get, Tyler? 76.01. I disagree with that. Should have 5 significant figures in the result. Yeah, there's 5 here, there's 5 here. Anyone? Nick, what do you have? Nothing. Okay. Yeah? 010. Okay. Let me see. Phosphorus. Ooh. 7.5. Okay. What do you get?
7.8.
Okay.
Said about.
Okay. 7.8. 23. Okay. And 1/8. Sorry about that. 1/4. Yeah, 1/8. So about 1.2. Or sorry about that. 12 point something.
I got 16.2.
Okay, 16.2. We need 5 significant figures. 16.1 what?
16.17.
17 what?
That's you.
Percent.
That's 4 significant figures. No, what's that?
Then it would be 16.1.
6.
Wait, hold on. Give me a second. There's a lot of 6s and 9s.
16.167.
Thank you.
Okay, there we go.
Thank you, Drake, for being the voice of reason. You're the voice of reason.
Just a reminder.
Yeah.
It's so. Why
8
do we
is
round?
a counting number.
No, why do we round to 5 significant figures?
Okay, 8 is a counting number. The reason where I'm going with this is how many oxygen atoms? 8. So obviously we're not going to be using any of these.
Yeah.
How many significant figures here?
5.
How many here? 5. And I'm dividing, so therefore my answer must have 5.
When we type usually oxygen, it's just 128.
0.00, right?
So why is it 58?
because this is to 0.00. And when I add up 16 of those, should I go on? Should I keep going? I can put all 8 of them up there. All right, but you see where I'm going with this? And since we're adding all of these numbers that are to the hundreds place, my answer has to be to the hundreds place. There it is, which now has 5 significant figures. Multiply by another number that has 5 significant figures. 5 significant figures, my answer. Kind of cascades, doesn't it? It all matters. It all matters. Are we done? Do you guys get this? I mean, how, honestly. Okay. Remember how many times I said to you guys this year that when things are easy, let them be easy. Okay? This is one of those things. Because here in a really short period of time, they won't be as easy. That should be nice. So, any new news today? Nothing going on in the tables that I should know about? Got new news?
I love Shelby. That's all I have.
What's that, Rachel?
Let's put the fun back in funeral. I put the hot in psychotic.
Let's have the what?
Fun back in
I got that one.
I put the hot in psychotic.
Someone made
Tables.
Okay, good. Oh, excellent. First set of movie.
Huh?
He's writing that stuff on there, just saying.
Ah, here we go. There's that, there's the end of it, yes. Yesterday? No. Everybody say hi to Mr. Huntley. Here, let me turn off the video so that